So this is the 5th subscriber special, and in this special we're going to have a look at making code a lot faster, very simply, and we're going to be doing this with numba. I am aware that there's also Python and other approaches, but I think this is the easiest to just show, and if you're interested in it, you can Google more for your own. So we're going to import some stuff. We're going to import numba, of course, or actually from numba import JIT or JIT, yeah, JIT. We're going to import time because I want to show you how much faster it is. We're going to import matplotlib.byteplotlib as plt, and from math import script. So we're going to write the same function twice, except with one small difference. Def get primes up to n primes is for number in range 2 to integer, and just making sure that floats would not crash this, and then we say prime is true, and I'll say for divider in range 2 skirt no int skirt of number plus 0.5, so it always rounds up, and then plus 1, so it includes the final number, so 25 would not become square root. And I'll say if number divider is 0, prime is false, break. And I'll say if primes will append number, return primes. Just to check this, print get primes up to n. I'll say n is 26. If you run this, 2, 3, 5, 7, 11, 13, 17, 19, and 23. That seems correct to me. So now what I want to do is I want to check how much faster we can make this. So I'm going to copy this, add numba at the end, and all we're going to do is we're going to add @JIT to the front of it. So what this does is it compiles it beforehand. So the first time it runs, it's going to be slower, but after that, it's going to be incredibly fast. And I'll show you. We'll say so times normal is an empty array times numba is an empty array, ends, or let's say, yeah, ends is good enough for now. Ends, I'll say for power in range 7, and I'll say n is integer 10 to the power ends will append n time 1, or time 1 is time 2, no, we'll do get primes up to n of n, time 2 is time. Actually, we can remove the white space here. Get primes up to n numba n, time 3 is time, and then of course we're going to store how long it took to do this. So we'll say times normal.append time 2 minus time 1, and times numba.append time 3 minus time 2. And we're going to plot all this, so say plt dot log log, and we'll say ends times normal label is normal plt dot log log ends times numba label is numba plt dot legend plt dot grid plt dot show, and we run this. Oh, and this should take about, oh, well, there you go. And you see the first time you run numba, it takes just under a second because it has to compile everything. But then after that, it's 40 times faster than the normal approach, right? It's a log-log skill, so it's always a factor 40 difference between what numba does, or how fast numba runs. Let me check. It says here x is 10,000, and this is x is, oh no, y, of course, that's what we're looking at. So y is 1 millisecond, and x is so it's 20 times faster here, and it's going to be the same over here and here. It is 13 versus 0.3, so yeah, that's a factor 40 difference. So, and all I did was added at JIT here, right? So I think that's a really cool feature. It is limited though, so if you want to do more with this, you're gonna have to look around a bit to what modules you want to use. But for simple stuff, this really makes a big difference. So I hope you enjoy that, and thanks for subscribing.